there's a couple of things I want to do to this Nintendo. I want to take it apart. I want to deal with the brown that's appeared on the case, at least on the lighter part. The darker part still looks okay to me, so I'm not going to work with that. And try and fix it. I got this for free because it didn't work. Somebody had tried to repair it previous to me and apparently not been successful. I haven't tried powering it up yet, but I want to take it apart and look at what's in there, what the previous repair job is, and what the state of it is, and then try and figure out what to do from there. The reason that the case is brown is in the 1980s, they would mix bromine with ABS plastic. Tons and tons of kids' toys are made out of ABS plastic. Modern 3D printers use ABS plastic. ABS plastic burns. In order to prevent it from burning, what they would do in the 1980s is mix bromine into the plastic. Over time, UV light causes the bromine to start to leach out of the plastic, and it gives you that kind of brown color that you kind of associate with electronics from the 1980s. The trick to getting the bromine off is to get it to bind with stuff in hydrogen peroxide and H2O2. And you need to basically coat the plastic in some kind of hydrogen peroxide solution. I'll be using a hair treatment, and add some UV light and wait a while. It generally works pretty well. Often people think that these electronics turn brown because they're dirty. While they are often dirty, and you can see here, this needs to be cleaned up. That's not the only reason it turns brown. No amount of scrubbing will get the bromine off. You might be able to scrape it to the plastic, but it's still going to be there. So this is after I've cleaned up the plastic quite a bit. It actually, just cleaning it really did help the appearance, but it's still got that bromine brown to it. So to get that off, I'm going to take the hydrogen peroxide hair bleach solution. This is a pretty cheap, common one. Picked it up off of Amazon. It's kind of nasty stuff. That's why I'm wearing gloves. I will admit, while I use gloves here, I didn't use gloves when I was taking it off, and that was definitely a mistake. I managed to, at some point, after handling it, I needed to move into sunlight, I touched my eyes, or rubbed my eyes, and it doesn't hurt right away, but after a while it starts to sting a little bit. So I rinsed out. I just used water and got it out, and I was fine, as far as I can tell. This stuff, I've seen it featured, I've seen it used by a lot of people to do this kind of treatment. It did end up working out pretty well for me. I did try using a UV lamp. The UV lamp didn't really work. It helped highlight where the problems were, but it didn't really carry out the treatment very well. Sunlight worked much better. The sun dumps out a ton of UV light. You don't normally see it because we don't have receptors in our eyes for it, and the lenses in our eyes generally filter it out. It turns out so do the cameras I use to try and record this. The UV lamp I got did help highlight how far the process had gotten. Like, you can see there's a lot of streaks, and then when I fold the plastic on top of it, it leaves kind of a streaky pattern in where it's removed the bromine and where it hasn't. But you can't really see it until you hit it with the UV light, and that kind of showed me where I wanted to give it a few more treatments with this process. I tried filming it. I tried taking pictures. I couldn't get it to show up on camera. It just looked like a big washed out mess. But like, to my eyes, it would luminesce. So I could see it, but I couldn't capture it on film. Usually these things, what goes wrong in old Nintendos or NESs. At the time, we only called it a Nintendo because there wasn't any other Nintendo yet. What usually goes wrong with these things is nothing too fancy. It's the connector for the game cartridge. After a while, it gets bent, it gets corroded. It just sort of stops working. And it's not like the data pins that stop working normally, it's the lockout chip. There's a chip called the CIC lockout chip in these that basically Nintendo would use to ensure that you had a genuine Nintendo game cartridge. And it communicates at kind of a higher frequency than the rest of the pins. And when the pins get a little, or when the pins in the game cartridge and the pins in the connector get a little flaky, you kind of get some noise, some electrical noise in the connection. And the lockout chip would get a little confused and not think that you had a legit game in there, and it wouldn't let the system boot. It basically would prevent the CPU from booting. And here's the mechanism. It's kind of a famous story that... So the Nintendo is like the American version of the Japanese Famicom, or the NES is the American version of the Japanese Famicom. The Famicom looks like a kid's toy. And the story is that when they were bringing the Famicom technology over to America, they wanted it to look like a piece of equipment that belonged in an entertainment center. And so like you've got VCRs that you would, at least at the time, a thing would pop up, you'd put your tape in, and you'd push down on the thing to play your tape. And the first generation of VCRs was really expensive. It was a really expensive piece of hardware. So the whole, at least according to this, at least the way the story goes, is the whole point of this mechanism for sticking the cartridge in and pushing it down and having that click is so that it mimicked how a VCR works. It's completely unnecessary. The Famicom is a top loader. You just stick the cartridge in the top and turn it on and it works. And what people think happens is over time, the up and down, clicking it in, clicking it out, it bends the pins a little bit when you do that. And, puts a little more stress on them than is absolutely necessary. And wears them out. On this particular system, that wasn't a problem. It really is just the power module isn't working correctly. This connector on the bottom here was never used. The Famicom could use it, but the NES never used it. The cartridge connector is just pressure fit in and pull it out. You can see this is where the damage to the board is. There's a lot of corrosion there that I need to get cleaned off, and then I'm going to have to remove all the solder that's in there from the previous repair job. Removing corrosion is fairly straightforward. Vinegar works really well. Don't need anything fancy. Rubbing alcohol didn't really work. I tried it. It cleaned the board up. It actually did clean some of the other dust up, but it didn't do much for the corrosion. So that was just kind of being patient with a pile of Q-tips and trying to get all the corrosion out. The problem with the corrosion is it's reacting chemically with the metals in the board, and it can get into the traces on electronics. If it does that, it can start to eat those over time, and eventually things will stop working and be that much harder to diagnose and repair, because you'll have to start jumping around damaged traces. That's going to end up being what I do here. I can see where the previous repair job, it scratched some of the surface off of the silk screen that was covering the traces so that they could bridge these pins to those traces. But it didn't work. It wasn't clean. And I couldn't really diagnose exactly what was wrong, but I figured I was going to rework all the solder anyway. The tool I'm using here is a desoldering gun. It came with a 1mm tip. Problem is the pegs I had to remove to get this cleared were 1mm by 1mm, and if you Pythagorean theorem that means the diagonal is 1.2mm, because it doesn't quite fit in the tip. So I picked up a 1.6mm tip, and all of the tools required to clean it out. So if you use this tool a lot, you do have to clean out the nozzle. And that worked pretty well for getting these out. Normally when you desolder something, there's a pump action desoldering tool. That works pretty well for removing single things, but if you're trying to remove a header that's got a bunch of plastic on it, I'm not very good at this, so I tend to melt the plastic, and I can't get all the solder clear all at the same time, so it's really hard to do. With a tool like this, you just put it up to the pin, give it like a second, you'll feel it melt, pull the trigger, it pulls all the solder into it from that pin, and pretty much always on like the first try, you'll get it cleared. All right, this is the power module. This is the part that is likely not working correctly. Sorry, it's working fine. The connections to the main board were not working correctly. I also didn't have a power supply. I had no accessories with this thing, so I picked up this third-party one. And see, this transformer on here is tiny. I don't really know what to make of this, so I'm going to test it. It does seem to put out 9 volts mostly consistently. As long as it's over 8 volts, it should be fine. The way this works in most electronics is there's a linear regulator that takes anything over like 8 volts, drops it down to 5, and with the right mix of capacitors and other components, it'll get a really consistent 5-volt signal, even if the voltage coming in is kind of basically a dirty power signal. What I'm doing here is attaching basically a jumper to the power button connectors. Normally these two pads I'm attaching it to are wired into the power button on the Nintendo. For this thing to function at all, I need those to be closed together so that I can, attach the multimeter to the various points and see if it behaves the way I expect. Because I know that the power module, I was heard that the power wasn't working correctly. I wanted to test this piece in isolation, and I didn't want to make any mistakes and like fry something that's harder to replace on the Nintendo and have a much more complicated rebuild job. Alright, so those big blobs of solder is where the main power comes in. You can see it's 9 volts. I know it says negative 9 volts. It just means I could have connected the leads the other way and get positive 9 volts. The middle pin on the linear regulator, that's the piece that's at this edge here, is ground, and on the red side, that was the in, and on the left side, that's the out. So the out you can see is at 5 volts, and it was like a stable 5 volts, or pretty stable 5 volts. This middle of these 5 pins here is the 5-volt power supply for the rest of the Nintendo. The right 2 pins are video and audio. I don't have the ability to test to see if those are working correctly yet or not, so I'm just going to pretend that they're working and deal with it if they're not. I need to remove this jumper I added. Luckily, I've got my handy desoldering tool, which makes it pretty easy to do. It does turn out that if this entire power module was completely hosed, it is possible to rebuild it. It looks like there's a lot of parts on that board, but there's really just 3 things you need to make work. You need to make the linear regulator work, and those are pretty straightforward. Everything has them. You need to amplify the video signal, because apparently what you get fed into that module is a correct composite video signal. It's just a very weak signal, so you have to amplify it. The power module is held to the main board just by these 4 like metal fins through these slots, and it's soldered into place on the pads. There's nothing else holding it in, so I have to put those back together. I think it was the previous repair job, and I kind of understand why this happened. Those 5 holes that are not shiny used to be shiny, at least on one side. Actually on the other side, the one you can't see right now. What had happened is they were only on the surface of the board, and somebody trying to fix them damaged them. They got ripped. What I'm going to end up doing is just routing around them completely. I didn't even put the pins that I pulled out of those 5 holes back in place. Kind of a quick description here. What I'm trying to do is get the metal tab hot enough to melt the solder so I can touch the solder to the metal tab without touching the solder to the iron. I'm pretty sure that's how you're supposed to do it. I don't always do it correctly. Occasionally I do touch the solder to the iron and it doesn't join as well. This forms a much better connection. Seems that patience is key here. I feel like I should tell you that I actually ended up redoing this part because you can see into the power module right now. You're not supposed to. When I took it apart, there were 2 pieces of shielding I'd removed, and I forgot to put them back on. I also didn't film me taking it apart and putting it back together. So yeah. I know a lot of people are intimidated by soldering, and I know, like I said, somebody messed up the previous repair job. Soldering isn't that hard. It might be hard to do really well, but doing a passable functional job just takes a little bit of practice. It might look like it's scary molten metal, but kind of what I'm trying to show is it's not too difficult, and you can get like a beginner kit. Here I'm just using magnet wire, which it's just a type of wire with a coating shield. I'm burning the plastic off the edges a little bit and tinning the ends. The tinned ends make this part way easier. I'm melting some of the existing solder that's already on a pin, attaching it to the magnet wire, and then basically just moving on to the next pin. So these are going to look a little out of order. I'm not attaching to where the original 5 pins went through. I'm following the trace through and attaching to the next component, because I know those connections are still good, and I know that the pins are damaged, or in this case I actually can't quite reach because they're supposed to connect on the inside between the motherboard and the power module, and I can't get an iron in there. I can't get the soldering iron in there. So I'm just attaching wherever I can find a connection that's supposed to be connected to the pin, I'm just attaching the wires to that. I should kind of fess up to another lie of the video here. I ended up redoing these wires too. The reason is I made them too short. It does work like this, but when I went to reassemble the Nintendo, I forgot about that giant heat shield I removed earlier, and the wires didn't quite fold out of the way enough. I ended up taking all of these off and putting them back on again. But since I'd already filmed it once, I didn't film it the second time. And you may not know, filming things makes you do them slower. So yeah, this part is basically, I did the same thing again, where I'm not attaching to where the pins were originally attached. I'm finding the next component in the chain that's like exposed on the surface of the board, melting the solder that's there, or adding a little bit and then melting the solder that I've added plus what's there, and attaching the magnet wire to those. The first 3 were pretty easy. They all went to pins on that blue connector on the side. That blue connector goes to the power button and the reset button, and it's pretty straightforward. These other 2 go to little tiny components that you can't quite see in this camera shot, and that's again the video and audio lines. And that's the last wire. So the only thing left to do is test.